I can find my mouse here. There we go. Hi, everyone. My name's Eric with BobCAD. I am the demo technician. And so basically, I am one of the tech guys here. I answer any questions, any technical questions you guys have in the software program. I also do demonstrations of the software program as well. So if there are any new updates, the newest version, let's say if you're getting into 4 or 5 axis, we can do a demonstration to be able to view what we're able to offer before you guys decide to upgrade. I also am doing the live events here every other Wednesday. So our next one is going to be November 20th. That is TBD. We don't know what the topic is yet. We normally send a survey and see what you guys are most interested in. The one most voted on today was Mill 3-axis Premium, so we'll be getting into that now. Basically, all I did, let's start from scratch here. Right when I open BobCAD V37 that I'm in, I'm going to go to the top and go to a not a new file, but an existing file that I've created. So under my recent files, I'll just double click on this 3-axis mill premium demo file that I've got. I'm going to blank everything out in the milling job so that we can start from scratch, setting up the the work offset and milling operations to be done in 3-axis. Mostly what we're going to be focusing on today is using a ball end mill to get a good surface finish on the top surface here, and then going down the walls of this sort of part here, and then down the dome surface to create the exact surface finish that I'm looking for this part file. And you can see I've basically got an assembly in here. I've got my part file. I've got soft jaws that's going to be clamping down on the stock that we're going to create here. Got a Kurt vise in here. And normally what I show before we get started in the CAM side of things, programming for the mill, in CAD we can sort of move all of these parts around to create the right assembly for us. I usually show real quick how we go to the top in BobCAD, go to Utilities. We can go to Translate. And basically, right, so like if I'm moving the Kurt vise over so the soft jaws can be at a certain distance between the two here, I can type in my translate amount over on the left. I can also pick a start point of translation. So let's say I want to sort of mate this point, make it coincident right along this point here. So this is my start point position, and then my end point position over on the left-hand side here. I'd highlight that, and then click on this point, and that will translate what I've selected to that specific location. And then I can, of course, select the geometry again and move it in the negative y direction to a certain distance there to space it out. But yeah, a lot of different ways to be able to translate things like this, rotate the parts, and be able to model everything that is going to be viewed and going to be machined and there on the table of the machine. So we've got our assembly, and we'll get started with the CAM side of things, programming for 3-axis Premium. We're going to go to the top, and we're going to go to CAM and start a new job. It will be under the milling job type, and I'm going to use my BobCAD 3-axis mill. Now, the BobCAD BC 3X mill, that is going to be a Fanuc-based G-code with the formatting with that machine. And there's a whole bunch of other machines in here built into the system. If I go down here, we've got a Haas 3-axis mill. We've got some other machines built in. If you don't find yours here, we do have a lot of machines, post-processors to format the G-code for your machine on our support page. And that website is bobcadsupport.com. So I'm going to select my BC3X mill. I'm going to go down to the bottom and click Stock Wizard, where it will ask me my workpiece. Now this is my finished 3D model so that I can make sure everything is cut to size. So I'm going to select my 3D model, and then I'll be able to see this in simulation, make sure everything's cut to size with the part file there. And then my next page, it creates a piece of stock around the workpiece. A rectangular piece of stock, if it's cut to be this sort of bar stock, I guess you could say, this cylindrical piece, I can click on cylinder up at the top left, click on calculate stock. And I've got some other options here, selecting to extrude the stock out from wireframe, select a solid model, select an STL file, or revolve some geometry around to create the 3D model of my stock here. Let me move this page over on my other monitor there. All right, looking good. Want to make sure I can see your comments at the same time. If you guys have any comments, questions, concerns, let me know. More than happy to answer anything that you guys have moving forward here. So after I've defined my stock, I can type in the diameter here and the height if I want to drop it down to where the soft jaws are going to be holding it. I'll type that in here. Then I go down to the bottom here, go to my next page. And then we have our machine setup. This is where I am defining my work offset. So if I'm touching the tools right here at the center of the stock here, there's some sort of way I can drag the tool over and get that exact location at the center of the stock. I would just click on origin all the way on the left-hand side here, and then click on this point. So this would be my new G54 work offset location. And I'm going to scroll down and click OK. I'm going to delete the milling job that I just created because I've got, sort of my template that I've already done, my existing milling job. So the one I just made, I'm going to highlight it down at the bottom in the CAM tree over on the left-hand side here. I'm going to hit delete on my keyboard. It's going to ask me, do you want to delete the selected item, the milling job? Yes. And we're back to the milling job that I have set up with the correct stock thickness there so that the soft jaws are holding on to it. 2.9 inches for the height of the stock. My machine set up at the top of the stock here. And I've blanked out the stock by showing or hiding the stock with this eyeball icon over on the left of the stock here. So blanking it out or turning it back on, my machine setup, and my features under the machine setup. So my first feature I created was an advanced rough operation. Now what I tend to do, I tend to blank out all of my features here, and then I can drop down a feature, which is basically a group of operations. And you can see all the only operations I have in this first main rough out feature that I've labeled is the advanced rough. And I tend to just highlight an individual operation each time so I can see, okay, this is what the advanced rough is doing. Then I can collapse the items under the main rough out. I can expand the next one, which is going to be finished top surface, this feature here. And again, it's only one operation, a 3-axis premium toolpath that we'll look at first, cuts a long curve, and it'll show the toolpath on the top here. So that's how I normally look at individual operations. Normally have them blanked out here, but look at exactly what I'm wanting to look at a time. So we'll get into the 3-axis, the 3 different tiers that we have. The first 2 are Mill 3-axis Standard, Mill 3-axis Pro, and then the third one that we're going to be looking at specifically here is 3-axis Premium. So the 3-axis Standard, 3-axis Pro are sort of in the same window here. If I right-click on Machine Setup 1 for any of my milling operations, we've got our drilling, tapping, our 2.5-axis milling operations here for like a profile cut or a chamfer along a straight edge, things like that. Then we'll go to the next one, which is Mill 3-axis. This includes our Mill 3-axis Standard and Pro that we'll look at for a second. Under my machining strategy, over on the right-hand side, we have our available operations. And these have our standard and our pro milling operations all sort of lumped in here in one. The first ones are the 3-axis standard, which include the Z-level rough, the Z-level finish, the planar, spiral, radial, and plunge rough operations. And then we have some we have our 3-axis pro milling operations after that, and some of them are sort of related to each other. You can see the Z-level rough and the advanced rough, the Z-level finish, the advanced Z-level finish, some other the planar and then the advanced planar in the 3-axis pro. We have some other 3-axis pro milling operations, our flatlands, equidistant, pencil, project curves where we can project a 2D shape onto a 3D surface, and steep shallow is a newer one here as well. So again, these are our 3-axis standard and pro tool paths. I started with a 3-axis pro with the advanced rough, and then we'll be getting into the 3-axis premium after that. So the 3-axis pro advanced rough that I started with, all I did basically was select my advanced rough here. I selected the tool that I'm starting with here, the 1/2-inch flat end mill, under my tool page. My next page, I have my different cut patterns. If I want to zigzag back and forth or start from the outside and sort of spiral my way into the inside of the stock there, different kind of cut options there. Set my depth of cut, my step over amounts, and allowance. I'm leaving 10 thou for the finish operations to clean up. And then how I'm entering into the stock. All these kinds of options you'll find in the 3-axis standard, but in the 3-axis pro toolpaths, I tend to use these. The advanced rough, something that a couple things I'll highlight would be the rest roughing here at the top. So with this one, I would tell the software, if I did a previous roughing operation with a larger tool, I would tell the software the previous tool that I used, corner radius on it. The software will calculate any areas the previous tool couldn't fit into and calculate that tool path to start right where we left off from the previous milling operation and avoid any air cutting there. One other thing that I'll highlight in the 3-axis pro before we get into the 3-axis premium would be, once I sort of skip down a few pages here, linking for each step over, gouge check to make sure there's no gouging of the tool or tool holder into the workpiece, and I get down to my advanced feed rates. This one I usually show at the bottom, my adaptive feed rates. I can set a minimum feed rate here. And so when the tool is getting into larger material at a time by volume, like into these corners on the inside, the software can calculate how slow the tool needs to move and keep a constant chip load. And that can reduce chattering at the machine. So a couple really neat features just to show in the 3-axis Pro roughing before we get into the 3-axis Premium surface-based toolpaths. Last page here is MDI, stands for manual data input. So if there's any G or M codes I wanted to add manually, I can add them before or after an operation here. I'm going to click Finish only because I have not made any changes to the toolpath. If I did make any changes, let's say I changed the step over or depth of cut in here or anything in here, change the tool, I would hit Compute so that it would compute the new toolpath for me. But there's not going to be any new toolpath. I haven't made any changes, so I'm going to click Finish. And I'm going to collapse this item for main rough out on the left-hand side in the CAM tree, and then go to the next one where we're getting into our 3-axis premium now. All right, so I named it Finish Top Surface, and this operation is called Cuts Along Curve. This is found by right-clicking on Machine Setup 1. We go to Mill Multi-Axis. So after Mill 3-axis, Mill 4-axis rotary, it's the next one down, Mill Multi-Axis. That's where our 3-axis premium surface-based toolpaths are located. Now the first few here are for 4 or 5-axis machining only. Wireframe is where you can select certain sync lines where the tool is going to be tilted at each one of those locations and go around a wireframe that you select. Multi-axis machining would be for 4 or 5-axis pocketing out, roughing out areas in multi-axis. Swarf machining to tilt the tool along a blade. In the 5-axis premium, we have multi-blade for impellers, port machining for porting. And the second to last one down, we have turn milling for 4-axis to rough out a whole lot, sort of like we're turning down the stock on a lathe, but with a milling tool here. Now we get into deburring, which is included in the 3-axis premium. You could use a ball end mill like this, or a lollipop tool, or maybe some kind of chamfer tool, and be able to follow along any corners on your part and break those edges. That can be done in 3, 4, or 5-axis milling. Then we get into our surface-based toolpaths. We'll get into the deburring after this part file and take a look at the surface-based toolpaths first here. So parallel cuts. First one we can look at here. The tool can go down any surfaces or across any surfaces I select, following along the geometry selected here. Cuts along curve. This is the first one that we're doing. I'm selecting surfaces on top of the part here as an example, and I'm selecting a lead curve is what we call it. You can see it here in orange. The toolpath is going to go perpendicular to that toolpath. So you can see in blue, that's the toolpath here, going back and forth across the orange as it follows the surface back and forth. We'll get into that one first. So I've got cuts along curve. I just opened my cuts along curve operation here in the CAM tree. Select my work offset. Define my tool here. So I've got a 3/8 ball end mill. And I am selecting my geometry here, my drive surface. So I normally select first. I'm selecting these 2 top surfaces here highlighted. Click OK. And then lead curve will be just this curve highlighted here in red, the one here in between the 2. So it's going to just create toolpath back and forth along this curve there. Couple of really neat features in the 3-axis premium that I normally go over. Here in the bottom, we have our maximum step over. So I could say, okay, maybe I want to step over the tool 10th thou every time. Or if there was, if I didn't have the 3-axis premium, and I'm doing this in 3-axis Pro, let's say I'm using the planar toolpath, for example, for this, right? And I'm using my step over, I'd have to go into the simulation and make sure that everything is cut to size. And if everything wasn't cut to size, sort of like a guess and check option there, I would then go back into the planar feature and change the step over accordingly to try to get it cut down to size. Instead of having to go into simulation, make sure it's cut to size, make sure the surface finish looks good in simulation, I can type in this box down below it, the cusp height. I can see that example here. The step over or the cusp height I can type in. Let's say I don't want the cusp height, or some people call it the scallop height, the certain tolerance level for the peaks of the material here that we're cutting out. Let's say I don't want it to exceed more than 1 thou. So if I type in that number here, just type in 0.001, you'll see the maximum step over above change automatically. So to achieve that desired cusp height of 1 thou, the maximum step over is going to be 38 thou step over. So now I know all along the part here that I'm machining, finishing up, it's going to be 1 thou. I don't have to go into simulation and check it. And if it's not cut to size, go back into it. With a 3-axis premium, that guesswork is not needed anymore. Over on the left-hand side, we can do one directional cutting, zigzag back and forth, or spiral around the surfaces selected. And this one I tend to use a lot also, this extend trim. So with this checkbox, turn it on, click on the button, opens a pop-out for tangential extensions. So if I click on the numbers here to show me an example, it's going to go 100 thou past the surfaces I've selected. If I type in a negative number, I'd shorten up the toolpath a little bit, but I want to make sure it's going a little bit past the surfaces to finish everything up on both sides there. Then we also have side extensions. So at this 50 thou, it's going to start 50 thou before the surfaces, before that start point there, And then after I finished up with the surface, it's going to go an extra 50 thou past the surface is selected. So a great way to be able to extend the toolpath to exactly what you need and make sure everything's cut to size there. Manipulate your toolpath very well there. Then I go to the top here. These are our different tabs. It's going to be a little bit different than the 3-axis Pro. You can see on the left-hand side, there's not all those pages of patterns, parameters, gouge check, all those. All those are up at the top here in these different tabs. So we've got our surface path tabs, got that taken care of. Next one, tool axis control. I'm selecting if it's 3, 4, or 5 axis machining. We also offer that. Gouge check. Here's our gouge check page, just like before in the 3-axis Pro. Make sure the tool and the tool holder doesn't have any collisions there. And then next is linking for each step over. Roughing, I normally show, this depth cuts option? That's what I normally show. So if I wanted to do multiple depth cuts, I can type in the number of roughing passes, how far they're going to be spaced out, and the number of finish passes and how far they're going to be spaced out. Then our last tab here is utility. I don't normally use this here. A lot of miscellaneous stuff. You want to type in your specific first cut feed rate, certain rapid rates, different things like that here. Then once I hit next down at the bottom, you will see the MDI page. So I just type in any manual GRM codes before or after the operation. I'll hit finish because I've already computed this. Don't want to waste time computing toolpath. I don't need to. And now if I look at it from a top view, you can see it's starting off of the surface 50 thousandths of an inch. You can see over here it's extended past the surfaces I've selected by 100 thou. And I can backplot and see the milling operation by going to my cam tree over on the left-hand side. So when I expand a feature like this and highlight it, see the toolpath, I can also right-click on an operation and go to backplot, 5th one down here. And this is where I can see the tool in my CAD geometry here. I can play through it, so I don't have to open up simulation and close out of it each time. I can do a quick backplot and make sure everything is cutting the right direction and doing basically what I want to do before I get into the simulation, make sure everything's cut to size and things like that. Please let me know if you guys have any questions moving forward here. This is our first 3-axis premium toolpath. There's a couple others we'll look at today with the surface-based toolpaths, and also look at deburring in the 3-axis premium also. So I will pause it here. You can also step through for each step of the toolpath here. If I get to the end here, I can see it move to the end, see how far off of the part it is there with the toolpath. It's going to step over and come back the next direction there. So I'll close out a simulation, or our backplot, I should say. Then we'll go to the next operation here. So we did finish top surface. Next is finish stand-up walls. And that is with the next operation in the surface-based toolpaths. That one is called morph between two curves. I'll show you the examples of the other ones here under 3-axis premium. Under the surface-based toolpaths, we have parallel to multiple curves. This is where I select my geometry in orange here. It will compensate for the tool and follow along that geometry selected, and then create an array of the toolpaths so you can see just steps over with the same toolpath all the way across the surfaces that I select here. Project curves. This is just like in the project curves in the 3-axis Pro, but this is more for 4 or 5-axis to keep the tool normal to the surface. But this does essentially the same thing as in 3-axis Pro. You can select 2D geometry. It will project onto a 3D surface and do a 3D engraving of that geometry selected onto the surface. Next is morph between two surfaces. Very similar to the morph between two curves. I'm selecting two surfaces here. It's creating an array of the toolpath from one edge of the surface all the way to the other side, and make sure there's no gouging on the sidewalls there. Next is parallel to surface, just like parallel to curves, but I'm selecting surfaces here, and it will offset from there and create an array of the toolpath outward. And flow line. The morph between two curves and the flow line, they both support forced undercutting. So if we're using a lollipop tool here, for example, the cutter could go up the surface and do undercutting here with this sort of tube type of shape here. So I'll go back to morph between two curves, and sort of an explanation with this one. I'm selecting my two pieces of geometry here. In orange, one edge, and then on the other side of the surface is selected, the second edge. And then I'm selecting all of the surfaces in between. You can see the toolpath starts along the first edge and morphs the toolpath to the last edge here. So it's a little bit different than the planar toolpath. Planar is just going to go back and forth in one specified direction. Let's say in the Y direction, it'll just go back and forth. It's not going to follow if you need to take a 90-degree turn or something like that. It's not going to follow into that corner. You can see that, like with this hourglass shape, it's going to start right along the first one and follow right along to the last shape here. And if there's any curves going around, taking a 90-degree turn or anything, you can do it all in one operation here. In the planar, you'd have to probably do 2 or 3 operations and still not get your get the right surface finish that you're looking for. But we'll get to the morph between two curves. I'll hit next. Set my work offset, my G54 location there. Next page, I'm setting up my tool. Again, it's going to be that 3/8 ball end mill. Now a little bit here on the tool page, I can type in my spindle RPM, my cutting feed rate, my plunge feed rate, all of those settings here manually, or I can use system feeds and speeds. And that will be calculated, if I hit finish here, that'll be calculated based on the material I've selected for my stock. My material library is found here in the CAM tree. It's right below where you see stock here. If I expand that option, you'll see where it says soft steel. That's the material type I have selected right now. If I double click on it or right click and hit edit, you can see the different material groups here. So whether I'm machining from carbon steel, aluminum, different types of plastic, we have feeds and speeds for each material type here. And we always recommend our customers contact their tooling manufacturer to make sure all of these numbers are dialed in for their specific tools, and don't want to break any tools or anything like that. So I select a material type and click OK. If I wanted to change the numbers in here, I can always double click on it and change the surface feet per minute, surface feet per minute for tapping, chip load per flute, plunge chip load per flute, and I can also change the tool material type in here as well. By default, we've got carbide tools, high-speed steel, insert tool. We can also add a different tool material in here as well. So I'll click OK, and then click OK for cast aluminum. And you'll see on the tool page here that we have different feeds and speeds for the cast aluminum now. Then our next page, we can select our geometry. Now I normally select the drive surface first, and the drive surface or surfaces is everything here. They're everything here in red. So starting from the radius at the top, working my way down to this bottom radius here, all the way around. Then I click OK. My first edge curves is going to be everything selected in red here. It's going to be hard to see with the stock, so let me blink out the stock here. So I go back to first edge curves. You can see everything here in red. It's this one going all the way around. So I'm just individually selecting these edges here, surface edges around the surfaces. Click OK. Second edge curves will be down at the bottom from my surface edge selection. So the edges of these surfaces down at the bottom here. Next, I'll click OK. And then, again, setting up my step over or setting up my cusp height accordingly. Let's say I just want the cusp height to be 1 thou. I'll type that in again. And you can see the maximum step over will change from 50 thou to 38 thou. And that's going to calculate it based on the tool geometry and the geometry itself of the part file. And as I went over before, we've got our trim and extend options, so we can extend the toolpath out a little bit further here. We've got our cutting method, one directional cutting, so it's going to spiral sort of all the way around the part, sort of that boss going all the way around there. Zigzag could go back and forth or spiral around. Next, we'll go to the top, go to the different tabs here. Next is tool axis control. Again, it's going to be in 3-axis. Gouge check, make sure there's no gouging of the workpiece. Linking for each step over. Roughing, just like before. I normally go into depth cuts, and we have a depth of cut option. Roughing passes, how far they're going to be spaced out. Number of finish passes there. There's some other roughing options there, but that I think that one's the most efficient one to use. Then we go to utility and some different miscellaneous options there for controlling your feed rates and rapid rates, things like that. I'll hit finish on this one. Now the toolpath on this one's pretty cool because you can see in the morph between two curves, it asks you not just a step over, but a maximum step over. So it will create a step over, a variable step over, you could say, all the way across the part. So on the top, you can see the larger step over, maybe somewhere between 30, 35 thou step over here. And then when I get down to the bottom, you can see a much smaller step over to finish up this radius down at the bottom. And it's going to keep that same cusp height from the top all the way down to the bottom of 1 thou. Then we get to the next one. Finish domed body is also a morph between two curves. So same type of selection here. We start with morph between two curves. Next page, set our work offset number. Next page, set our tool and our spindle RPM and cutting feed rate. Again, set to cast aluminum based on the material type that I've selected. And then step over, let's say cusp height of 1 thou. And the geometry selection just to see. Drive surface, these two surfaces here. The first edge curves will be the same selection as my bottom edge curve from the last operation, starting here along these edges. And then second edge curves would be down at the bottom of the last surface I've selected. I click OK. And then same tabs over here. We can go quickly. The tool axis control, the gouge check, linking for each step over, roughing, and utility. I'm going to hit compute because I just remembered I changed the step over for this one. And I also changed the step over for the first morph between two curves. So let's right click and compute the toolpath there. A little bit smaller step over. Next, after that, we've got an advanced Z-level finish, just following from where I left off down to the bottom and coming back and finishing up the top radius there with a smaller tool. So we will take a look at the simulation. I'm just going to go up to the top and hit Start Simulation. And let me know if you guys have any questions so far with what we've gone over today. And we'll be getting into the simulation here. Now I can show my stock. I can show my, well, I can show my workpiece, but I'd rather show the fixture. Oh, I don't have the fixture selected. So I'll close out a simulation. I want to define my fixture here. That's going to be over on the left-hand side in the CAM tree, right below machine setup 1. I can right click and go to Fixture and reselect. I'm just going to window select everything, and then I'm going to click on my part file again to deselect it and click OK. After that, I go to simulation and I'll be able to see it, make sure that there's not any collisions between the tool, the stock, and the fixture that I can show here. And I can make sure I'm not going down too far of a depth to hit the soft jaws and things like that. I can set my run speed time and hit run. So the first one again is the advanced rough. So all that's doing, that's under the 3-axis Pro. Depth of cut and step over, I think, set to 200 thou, going all the way down. If you're interested in the advanced roughing, I also did the intermediate steps. So if you get into the advanced rough a whole lot, and you can see how much material is remaining for a finish operation, that's way too much material to cover. I did the intermediate steps of 2 steps. So in between each step down here, each depth of cut, it's going to come back with the tool from the bottom, work its way back up, and in between each depth cut, it's going to create 2 steps in between them, and sort of like a semi-finish or semi-rough operation. Excuse me. I think it's a semi-finish operation before we get into the finish operation, so you can see how much less material is remaining for our first surface-based toolpath here. All right, so we can speed up the process here, but you can see it starts a little bit before the surface is selected, goes a little bit past the surfaces here of 100 thou. I can look at it right from the front view here, we could say. Make sure it's machining everything that it can on these top 2 surfaces. And then from there, it's going to work its way down. That was pretty quick. Let's start from after the roughing operation. And then after this, the first one was the lead curve option. Next one is morph between 2 curves. We'll look at that one a little bit more, because that's going to start from that corner and work its way down. Again, it's doing a larger step over at the top and then transitioning to a much smaller step over down at the bottom radius, so that everything is cut to size by 1 thou of a cut tolerance. And there's some ways to make sure that everything is cut to size there at 1 thou. Once I'm done with my simulation, we can take a look at that. There's a few really cool options that I normally go over simulation a whole lot. Down at the bottom right, where I am located, let me move me up at the top right corner here. So down at the bottom of simulation now, you can see different tabs. This blue tab first is Cut Sim, and that is for being able to save your stock that you've machined here as an STL file. So once this is finished up, another 2 seconds here. So this is my finished stock file. After all of the milling operations have been done on it, I can then go here and save stock as an STL. That could be good. Maybe we get into that at a later date of 3-axis milling, where you can save an STL file like this. You can load it back into BobCAD and tell the software, this is what I've machined, and if there's any other area of the stock that needs to be machined, only mill that area from my stock here and avoid any air cutting. The next tab here is Analysis. This is where I can see if everything's been cut to size. I drop down here for analysis, and I go to the fourth one down, deviation, and hit refresh over here to the right of deviation. It will show me different colors here on the stock depending on how much material is remaining. Now you can see the cut tolerances here in green is plus or minus 8 thou. If I zoom in to the bottom here, we've got this teal color is 8 thou to 26 thou, and this dark blue color, there's more than 64 thou remaining down at the bottom here, because that's what the soft jaws have to hold on to, so I'd have to flip the part over and do a facing operation on the bottom of this part here after we're done. So, but yeah, the deviation report, that's really good, because then I can see if there's any gouging. It would be showing in yellow, orange, or red into the part file that I've selected. And I can also make sure I can get an exact number here rather than just plus or minus 8 thou. That is on the next one. Yes, so that's the next tab over, measure. And with this drop down here, I normally go to the first one, points, and I can click on a certain point and it will tell me the specific deviation. This one's saying plus or minus 1/10, 1/10,000th of an inch on this top radius here. Let's go to, maybe there's something with a little more ridges like down over here. Click at the top of this peak, and it's giving me 7/10. 7/10,000ths of an inch for my deviation. So that's a great way to be able to see the deviation. You know, our cusp height is less than 1 thou. And so we will close out of our simulation. That's it with this part file. We'll get into deburring next in the 3-axis premium and call it a day. Before I open up a part file for that, let me know if you guys have any questions, comments, concerns in the comment section there. More than happy to help with anything that we've gone over so far with the surface-based toolpaths in 3-axis premium. All right, no questions so far. I'll get into the 3-axis premium for deburring here. We could get into something, sort of quick here with this part file that I've come up with. The shape of a bottle mold. This is my go-to, and drilling some holes. If there's a bunch of different hole sizes, you can always go to creating a new milling job, creating your stock, and creating your machine setup. This is where I'm defining my work offset down at the bottom left corner here. And then I can go into drilling very easily. When I right click on machine setup 1, you'd have to go into mill drill hole, select the hole sizes for each one, and then separately do it again for the next hole sizes, and so on and so on. Up at the top here though, when I right click on machine setup 1, the third option down is hole recognition. So I click that. I can click the solid model and click OK. It will tell me all of the hole sizes in this pop-up window. I've got 1/2 inch holes, and I've got 1/4 inch holes here. It'll tell me which ones are which. I can tell the software whether I want to add a chamfer operation, whether it's a blind or a through hole, and whether I want to do a tapping operation with it too, or counterbore operations. Once I hit compute, it will compute all the toolpath down here at the bottom of the cam tree. My 1/4 inch center drill and drill, I can delete that one. My 1/2 inch center drill and drill, that was just created. And you can set up whether you want to do a center drill and a drill operation in each feature under the hole recognition, if you want to do a pecking operation, if you want to do all kinds of stuff, set up a whole bunch of rules. It's up at the top under cam, and then under knowledge base, the icon right next to the NC editor here. So I click on that icon, and this is where I can set up different rules. So for example, with this one, if I'm doing a chamfer, if the chamfer is less than 625, it'll do a chamfer drill by default. If it's equal to or more than 625, then it will do a chamfer mill operation by default. Scroll down a little bit more. If the depth, this is kind of a weird formula, but if the depth is less than 3 times the diameter, so if it's a more shallow drilled hole, it'll do a single depth, and then if the depth is a little bit deeper for the hole, it will do a pecking operation by default. And you don't have to say 3 times the diameter. You could say if the depth is less than half an inch, just do a single depth. If the depth is more than or equal to half an inch, then do a pecking operation. Then you can save that for each time you're doing a drilling operation for any 3D model it works on. And it also works on every side. So if there were holes on the side of the part, you would then create your next, maybe a G55 work offset on the side of the part, and then select the hole recognition, select the solid model again, and it'll pick up the holes based on that side of the part there. So really like the hole recognition option. And then we could get into 3-axis pro roughing and then do the deburring on this afterward. So first I'm going to go to machine setup 1, go to mill 3-axis, select my geometry. I tend to, and this is also a good rule of thumb for the 3-axis standard and the 3-axis pro, selecting the solid model and then selecting a boundary to contain the toolpath inside of. That way, if there was any kind of boss on this 3D model, fixture, things like that, any clamps that you need to avoid, you can select that geometry here, and the BobCAD software will detect that, make sure there's no collisions, and it will just contain the toolpath inside of the boundary here that I've selected. And I've just selected the surface edges around the mold for the boundary. Next, top of feature, I'm starting at Z0, working my way down. Then I'm doing an advanced rough operation, and I'll add a planar toolpath using a 1/2-inch flat end mills to start with. We have some different cut patterns again. In roughing, zig or zigzag back and forth. Start from the center, work our way out. Start from the outside and work our way in. And then we have our high-speed machining options. Morph spiral would start at the center of the pocket here and work its way out at each depth of cut. And then we also have adaptive roughing. It's also a spiral toolpath, but this is our trichoidal milling as well. If you guys are familiar with BobCAD-CAM or other CAM software programs, this would be dynamic roughing or dynamic machining here. Same toolpath, just a little different terminology there. So this is our trichoidal milling and our high-speed machining option as well, keeping constant tool engagement. Then our next page, we have depth of cut, step over. I'm going to do 200 thou again for this one. Set an allowance. Set how I'm entering into the stock, whether I want to plunge, ramp, or spiral into the material, entering into the stock. Again, we went through our rest roughing options, pretty cool one. Machine flatlands, if there was any flats down at the bottom inside of the boundary that I'm milling out, it will do an extra cut to machine those out, the flatlands there. Linking for each step over, our gauge check page, our advanced feed rates to keep a constant chip load that we went over earlier. MDI for manual data input. Then we get into our planar toolpath. I'll do a 1/4-inch ball end mill. Next page, zigzag back and forth. 90 degrees, we'll go back and forth along the y-axis and set my step over. Let's go 20 thou. So yeah, again, just like as I mentioned here in the 3-axis Pro, I'm typing in my step over of 20 thou. I have no idea what that's going to look like on my finished model until I get into simulation and do that sort of deviation check. If I use the 3-axis Premium, we have that that cusp height option, so I don't have to worry about that guess and check sort of routine there. Then lead in, lead out. If I want to extend it out a little bit further, the toolpath, linking, gauge check, advanced feed rates. I'll hit compute. And just as I described earlier with the 3-axis Pro, in planar, it's going to go back and forth at a 90-degree angle like this, or 90-degree angle being along the y-axis, vertical here. So up and down, you could say. But say if, this is just a bottle shape, so it's just going across the x-axis. Let's say it took a 90-degree turn here and went down. The planar toolpath would just keep going back and forth like this. But in the morph between two curves, it's going to start in this direction, and it will actually follow the curve, the bend of the 90-degree elbow, to give you the best surface finish possible. So couple neat things to be aware of between 3-axis Pro and 3-axis Premium for a finish operation here. I'll close out of the back plot there, and we will get into the deburring. I would right-click on Machine Setup 1. Again, the 3-axis Premium is found under Mill Multi-Axis. I go to Deburring. Next page, set my work offset number, one being G54. Set my tool. Let's do a 1/4-inch ball end mill. That same tool as my finish operation. Then we've got part surfaces. So normally I have to rack my brain with this one here. So this is our geometry selection for deburring. Part surfaces, I believe I normally select the solid model, click OK, and then we're just going to leave it at that for now. I'm not going to make any other changes in these until later. My next tab up at the top is tool axis control. I want to make sure I'm setting that to 3-axis and linking for each step over. So I'm going to hit compute, and we'll see what it's able to do in 3-axis on the part surfaces I've selected, the whole 3D model. It's going around, it's even going around the bottleneck here to start with, and then following along the shape of the outside of the stock, and then the shape of the bottle, and then all of the holes as well with that ball end mill. Again, we could use a chamfer tool, we could use a lollipop tool, so we could do undercutting with a lollipop tool as well in here if you've got anything like that. Close out of back plot here. Go back to the deburring. And so I've selected the surfaces. Now the next option down, I can exclude curves, or I can include curves. Let's say I only want to include the holes here, for example. I'm going to select the edges of the holes. The wireframe is giving me trouble here. The wireframe of the holes. So I select all 6 of them and click OK. Hit compute. Now it will only create the toolpath for the edges that I've selected. Let's say I go back into the deburring. Instead of including what I want, exclude what I want. Now I just don't want to go all the way around the outside of the profile here, I just want to break the edges on all of the holes and the inside of the bottle shape here. And maybe also I don't want to do the bottleneck. I don't want to mess up the mold shape. I just want to go around the outside there. And click OK. Hit compute. Then it will compute the toolpath, just that profile of the bottle shape and the holes. And then what else do we have? Next one down, we have at a constant width. I can type in the number, so the constant width or constant depth down into the stock, and I can type in the number here. Next, trim or relief. Relief will actually enter into the corner a little bit more like that. Climb mill or conventional milling options, and number of cuts as well. Flat or round? Interesting. I think this is a newer option. Flat, you just go along to create a chamfer, or rounded to create more of a fillet, a radius around the corners, and the number of cuts you want to do here. Let's say we want to do 3 number of cuts, like we see here. Let's see, I don't usually use these a whole lot. Extensions, overlap. So this is basically setting a lead in and a lead out here. And your cut tolerance. We're doing 3-axis and clearance options for the holder, the arbor, and the shaft. And our last tab here, linking. For each step over, you can set a retract amount, those kinds of options here. And so we'll hit compute again, and now you can see 3 passes inside of the geometry here, inside the holes too. But yeah, you can use a ball end mill like this. If I go to my tool page, go to the tool crib, see what categories we have now. We've got a whole lot of categories for deburring now. This is newer. If I go to, for example, chamfer mill, and go right into that category, select the diameter of the tool here, bring it into the tool crib. I tend to drag and drop because I'm more familiar with the older versions of the tool crib and the tool library being in separate windows. So I tend to just highlight the tool library tool right here and click OK, and it doesn't change it for me. So I tend to make a note of drag and dropping it in to the tool crib so that it is the selected tool in here. We got our chamfer tool. I'm going to just do 1, let's see, flat, 1 pass, and let's do, yeah, let's just do the holes in the shape of the mold here. I'll hit compute, just that last profile right there. There we go. It will only do the toolpath that it's able to fit into. You can see there's no toolpath on the smaller holes, but there is toolpath on the larger holes and toolpath on the inside of the mold here. So a lot of cool stuff. You can see where it's starting right there. And we can also see in simulation it will remove that material as well. We get into doing the center drill and drill. Oops. Peck drilling for the 1/2-inch holes here. I was doing threading with this as well. That sort of brings up a good topic also. When you go into cut sim down at the bottom here and save as a stock STL file, it will also save threads for you that you create in your stock. So if you want to do any 3D printing with threads, things like that, you can easily do it by creating a thread in here and saving the stock STL file. So here is our advanced rough and advanced planar toolpath. And then we'll look at the 3-axis premium, which offers the deburring toolpath as well. So of course there will be, pretty sharp edges. You'll have burrs along the corners here or along the corners of the holes. You can use a chamfer tool to come around and break the edges. And there you go. So everything looks good. We close out a simulation and we would hit post up at the top. It will generate the G-code over on the right-hand side here, down at the bottom. I would right-click anywhere in this window and go to Save As. I can save it onto my flash drive and send it over to the controller of the machine from there. And yeah, just to recap, if I go back and right-click on Machine Setup 1, I go to Mill Multi-Axis. We went over deburring just now, and we went over the surface-based toolpaths, the ones that I normally use, the cuts along curve, morph between two curves. I like parallel to multiple curves if you're trying to create an array of the toolpath like this outward, but I tend to use morph between two curves so it doesn't give you those sort of weird scallops. It gives you a better surface finish with morph between two curves. Project curves, morph between two surfaces, parallel to surface, and flow line. If there's any questions that you guys have that we went over today, please let me know in the comments section. I'll be ending it here in the next couple minutes. And I want to thank everybody for viewing the webinar today. We do this every other Wednesday. So our next one is going to be November 20th. And again, the topic is to be determined. We usually send out an email with a survey and see what you guys would like to see for the next one. I know the last couple ones, the last one we did back in October was for thread milling, and you'll see it on this page here of the recorded live events on our support page. And thank you, Robert. Appreciate it. Thank you for viewing the live event today. Hope to see you in the next one. Not sure what it's going to be, but I'll be ready for it. We go anywhere between, laser, plasma, water jet. We do 3, 4, 5-axis milling like this here. We get into lathe, mill turn, any type of thing that you guys are interested in seeing. Please let us know. You can call or email us. Let us know what you'd like to see in the next live event, and we want to make sure that these live events are tailored to exactly what you guys are interested in looking at and learning about. And I want to say thank you guys again for viewing the live event today, and I'll log off of here and hope to see you in the next one. See ya.